I think we're there. Can everyone hear me okay at the back? If the mic starts to drift and you can't hear me, just, we'll just say something. As I've already said, good evening all. Thank you all very much for coming out. It's a real privilege and pleasure to come up from London to speak to the Manchester AWS user group. I mean, it's great to be finally presenting in person. Our clients tend to, like a lot of people, just stay at home. They want to have a virtual Zoom call or Chime call in our case, which is fair enough. But we don't often have the opportunity to talk to face-to-face our clients. Like with any interesting topic, there's not enough time, I don't think, to talk fully about this in the 45 minutes, but I'm going to do my best. What this talk hopefully will not be is death by PowerPoint. There's a bit of machine learning in here. I'm not going to go into the maths or the nitty gritty, and I hope not to be one of those blockchain crypto people that bores you. Or I'm not going to pump a coin. I'm not going to tell you to get into some terrible coin. But I hope you will learn something. I'm trying to teach you something about these two services and, in a way, evangelize them to encourage everyone in this room to start building with both Amazon Sagemaker and the managed blockchain. So a little bit about me. I'm a machine learning engineer in the professional services part of AWS. If you don't know what that is, it's sort of the client-facing or customer-facing consulting business within AWS that aims to make large institutions' cloud journey a reality, or it helps them bring to life what they're trying to achieve. So in my case, I've worked with AstraZeneca, more recently Ericsson, and who's my other client? How rude of me. My most recent client is going to be BPX, and it is essentially doing the same thing for them. It's building out their MLOps platform. So it's going from, hey, we've got all of these algorithms running on premise. How can we shift this to the cloud so that our data science teams across the world can make use of Amazon SageMaker? So without further ado, let's jump in. Very briefly, in agenda, introduce myself. I won't go into too much of a deep dive about Amazon SageMaker. It's existed for quite a while. I think majority of people in this room will know a bit about it. Bear with me, the Wi-Fi keeps trying to let me join. Give me one sec whilst I try and... No, if it keeps popping up, we'll deal with it. I'm going to talk a bit about the Amazon Managed Blockchain. I think this is something that a lot of people haven't worked with. In fact, put your hands up if you have worked with the Amazon Managed Blockchain or stood it up. Well, that's good. It's good to hear. Preaching to the right choir. There's a reason why people don't spin it up. There's not much going for it at the moment. Sorry, Amazon Managed Blockchain product managers. It's pretty much just a single node within a particular network, in most cases the Ethereum network. But it does do a lot of the heavy lifting, like a lot of the AWS services, but it is also very expensive. Leave that running over like a month, you're gonna get a very large bill. Of course, what is the title? It's the marriage of these two sort of key technologies. We'll go into that a little bit, and I'll let you decide whether you think it's the perfect marriage or not. But I have an opinion. And then at the round off at the end, I won't necessarily conclude anything, but we'll just almost open up to the floor for questions and enter into a discussion around what actually can be built and where these two worlds are going, because there's an interesting space right now. At the end, I hope you'll be able to describe some of the fundamental concepts and possible applications of the blockchain technology, understand the advantages of using it in certain IT problems. I don't want to push it too much. I'm no blockchain expert. I just think it's a very interesting space. Identify when to use Ethereum, which is sort of the key focus of something I built that I'll be showing at the end. Understand how state-of-the-art ML image generation works. We'll dive into that a little bit later, and it sort of ties into something that I built again. And then understand what use cases sort of exist at the crossroads of these two worlds, which is ever growing and at the forefront of technology all around the world. Not going to do death by PowerPoint, but here is Amazon SageMaker. Put your hand up if you work with SageMaker. Actually, not as many as I thought. What interesting, okay. But I mean, SageMaker has existed for quite a while. Amazon or AWS would not be a serious tech player if it didn't have some kind of machine learning platform to offer its clients. So AWS had a bit of an advantage starting out. and moved into this space quite quickly. But I mean, to meet our customers where they are currently on their machine learning journey and sort of help them achieve specific business outcomes, we currently provide sort of broadest and most complete set of ML and AI services for our builders of all level of expertise. So at the top, we've sort of got our services. This is what most people tend to interact with. You know, it can easily add intelligence to any application without really needing any specific ML skills. In the middle layer, we've got Amazon Sagemaker itself, which sort of provides every developer and data scientist the ability to train, build, deploy their models at scale. And then at the bottom, we've sort of got what the expert practitioners will use, or people within a research group at OpenAI or a particular university, so they can develop on the framework of their choice, and make use of the AWS deep learning AMIs, the Amazon machine images, which are configured with all the latest versions. I'll quickly leave this up. This is, I think, now a little bit out of date. Some of the new services or features aren't quite as new. As I mentioned previously, Sagemaker has a lot of services and they're ever growing. We typically split them into 4 areas. This is, these 4 areas really address the needs that the ML builders have when dealing with every stage of the model's lifecycle. So we've got data prep, the model build phase, training and tuning, and the deployment and the hosting. I'll just sort of highlight a few key ones. Pipelines, that's quite a recent one and a very powerful one. This has enabled entire, very large data science or machine learning teams to collaborate very easily with their sort of CI/CD pipelines. And this is what the focus has been, or at least what the teams I've worked in with AstraZeneca and Ericsson, that's been the real focus of what they've been wanting to achieve. They've gone from, in some cases, working in notebooks, siloed in different teams, but within Sagemaker Studio, you can bring it all together, and pipeline makes that life a lot easier. Clarify is another really interesting one. In fact, when I joined AWS, I didn't mention I've been at AWS for 2 years now. I came straight from university, did a bachelor's in physics and master's in machine learning, and got a very, very quick entryway into working with Clarify. I got the beta before it was at reInvent, and for any football fans out there, did a fantastic or really interesting bit of work working to explain how, essentially why all the different goals were scored in the Bundesliga season. So Clarify is very powerful. We see a lot of clients very interested in that in a world where being able to explain why this black box is doing what it's doing and affecting millions of people's lives, Clarify is, that's a real priority for a lot of senior stakeholders and businesses. And something like Edge Manager, I've not worked with it myself, but this is it delivers machine learning model monitoring and management for edge devices, as one might expect. There's sort of 3 ones I wanted to draw upon. Moving into the Amazon managed blockchain. So I'm pleased no one's worked with it, because therefore I can give a bit of a day 0 lesson and start from scratch. I can almost treat everyone as if they've never used it, because they haven't. So for customers who are looking to execute their transactions or a particular transaction in a decentralized way, Amazon managed blockchain, which is a few years old now, provides a fully managed, as is always the case with AWS services, blockchain service that takes away a lot of that heavy lifting. So there's 2 key ones. I won't be talking about the QLDB too much, but this is ideal for customers that are looking to maintain a complete and verifiable history of data changes in a particular application, but they're not particularly interested in it being decentralized, which is what sort of traditional blockchains focuses on. And then we have the Amazon managed blockchain. As I said, fully managed. It enables multiple parties to transact and share data directly and securely. So the next section, I'll go into a little bit of detail about what blockchain is and focus in on some of the benefits of it. So what is blockchain? What is blockchain? It's been the focus of the last 3 years of news and thrown around there. What is it? I mean, who wants to try and give a good definition of it? Put your hand up if you're brave enough. Yes, sir.
A cryptographically signed ledger of transactions.
It's pretty good. What is it? Blockchain is a peer-to-peer network in which distributed participants maintain shared append ledger transactions. So pretty damn spot on. And as I said, with this technology, multiple parties can transact data and share data securely. It's not just a sort of hub for cryptocurrencies to or digital assets to sort of exist and then people to trade in. There's a lot more to it. It's a very game-changing technology. Won't go into too much detail here, but the key takeaway is that blockchain builds trust in a network and eliminates the need for a central authority in just business networks generally. You know, if you think about as quite a good one, banks or some sort of payment provider, they can be cut out and they often take a fee, don't they? I mean, something like Amex or PayPal, they're taking a certain cut of every transaction. If that can be eliminated, it's, you know, the customer is a winner, everyone's a winner. A blockchain network typically has three main components. One is the distributed ledger, which we've spoken about, you know, the append only, the immutable ledger, which no one can make any changes to. In the case of an Ethereum network, the consensus mechanism, and then the smart contract execution environment. So, I mean, in conventional networks that I've just spoken of, the consensus mechanism is typically a centralized database. You know, the administrator has the authority to maintain and update the database. Let's think of credit card, credit rating providers, or even the government just maintains a lot of information on us. Since blockchain is decentralized, without any single one authority, you know, a consensus mechanism that can agree on the current state of the ledger and all the information on it. This can sort of guarantees that all nodes on the network are synchronized and that transactions are actually legitimate. And then the final one I mentioned is the smart contract. This is a sort of self-executing contract with the terms of the agreement between the buyer and the seller. And this is obviously the sort of key technology for NFTs that sort of go into a little bit. And given it's written into lines of code, it's not, you know, you can't change it. They permit trusted transactions, and the agreements themselves can be carried out amongst disparate anonymous parties. I mean, there's huge Bitcoin whales out there. No one knows who they are, but they can trade with or enter into an agreement with someone who's just looking to spend a few pounds or a few hundreds of pounds. So why do our customers care about this at all? And I don't actually have any hard numbers, which Amazon loves, by the way, if you didn't already know. The Amazon managed blockchain space has exploded. I think they're rapidly hiring. I was on a call the other day with the product manager who was talking about the next year to 2 years to 3 years product pipeline and what they're looking to bring out. And they're going from what I described to be a pretty average service with not many features or not much going for it. And I'd tell you what, it's going to be quite impressive. And I think I think there's going to be a lot of growth and revenue in this space. But why do our customers care about it? One is cost. You know, the distributed ledger itself can reduce operational costs. As I mentioned, if these intermediary services like PayPal sometimes charge between 2.9 and 4.4% of that. If you can eliminate that middleman, you can quite easily trace products and transactions all the way back to their roots, which does contribute to large cost savings. The next is transparency. Blockchain technology does provide a very high level of privacy to ensure the transaction details are shared amongst all the participants in the transaction. And the final one is it's simple and secure. Don't worry, I've not got too many slides on this, but let me go through the high-level features. It's fully managed. Surprise, AWS does a lot of the heavy lifting. Trying to spin this up on your own is very difficult, and to enter into the space, you need not only in some cases a bit of hardware, but some pretty advanced software, and all of it's managed for you. You can check how much it's costing you and quickly pull out of it, like with a lot of our services. It's worth noting, to those that know much about this space, that AWS is the only provider or vendor that actually offers both Hyperledger Fabric and Ethereum, which I'll go into in a bit. Of course, it's very scalable and secure. Job zero at AWS and Amazon is security and privacy. That is true of the managed blockchain, and it will scale with a lot of your other AWS infrastructure. And as we'll see at the end in demo, or not a demo, but what I will describe as one of the projects I've given, it integrates really nicely with all of the other AWS services, you can actually get something very powerful. The managed blockchain is a very nice portal into the sort of crypto and blockchain space for a good AWS developer. If you're familiar with a lot of services, you can very quickly, I think, develop a decentralized app. Or in certain cases, I've seen people that will spin up a particular node or a validator node for the new Ethereum network, the proof of stake network, to actually just validate some of the Ethereum and make money on it. As if the point hasn't got across, I'm really keen for everyone to start moving into the space and developing on it. And then the final one, why is Amazon blockchain really good? It improves reliability. I'll quickly fire through these, which are the two that are offered. It's Hyperledger Fabric, mentioned before, private permission framework. I don't know huge amounts about it, but it's been around for quite a while, and it's very suitable when there are strict, stringent privacy and access controls among a few set members. So where this is often useful is if there's a few quite security-focused organizations that all want to work with together or transact something, but you actually want the data visibility or the transparency to be siloed between them. So you want to cut costs with these transactions. But in the same way that a VPC has subnets, Hyperledger Fabric has something called channels, which means that only certain members of let's say, team A or company A, within that network, they can't see anything within company B. And the second is the Ethereum blockchain network. And this is public and permissionless. And this is, as we may or may not know, common platform to buy and exchange digital assets, such as NFTs. That is what a large majority of NFTs out there on OpenSea or any other platform is minting their NFTs on. Does anyone know what the merge is, out of interest? I've got one individual. The merge, so previously, this is actually worth knowing, and it's an important point for something I'm about to show you. But one of the reasons Bitcoin or cryptocurrencies have a lot of stick is because they use something called proof of work to validate cryptographic transactions. This requires hardware. AWS is in the cloud, there's a data server somewhere, there's a data center somewhere. The same is true of crypto, sort of operating in the ether as it were, but there are computers, the nodes around the world that are computing this, and it's very energy intensive, which of course is affecting climate change. What Ethereum aims to do, and this it's created a sort of spin-off, Ethereum 2.0, which uses something called proof of stake rather than proof of work. It's you stake some of your coins, and that's used and it's quite technical. I can't say I fully understand it. Those staked coins are used to validate all the new transactions that are taking place and to validate the new blockchain, which is of course getting longer and more complicated. And the merge is Ethereum 1 merging with Ethereum 2. So the proof of work network will merge with the second, such that it won't be using physical hardware, it won't be burning away and contributing towards climate change, which is a good thing, absolutely. What are some current common use cases? Get through these quite quickly. I mean, trading requires many different organizations, such as importers, exporters, banks, shipping companies, all to work together. Using the managed blockchain, these consortiums can create a network where all parties can transact and process trade-related paperwork electronically without the need, again, for the central trusted authority. Now, unlike other processes that require trade-related paperwork to go back and forth between stakeholders, sometimes in certain cases our customers say 5 to 10 days, these transactions can be built and processed immediately. The second is track and trace. You can improve the transparency for goods movements across suppliers. It's obviously very important now with supply chain issues that we're seeing across the world. The mic's drifting a bit. Can you hear me okay? Yeah, great. The next is retailers, customer loyalty programs. They're really important. By partnering with other retailers and banks and third parties, you can often offer a more comprehensive selection of customer rewards. And the final one is healthcare, where patients' data can be shared really securely. And many more. Quickly pump through these. Now, joined the Amazon, as I mentioned, Amazon Managed Blockchain Product Manager, Pipeline Roadmap, and he was saying there are a lot of issues that our customers are facing when dealing with the managed blockchain, which you can see here. There's not just one chain out there, not just Ethereum, there's Solana and a bunch of others, and aggregating data from all of them is extremely difficult. There are services like Etherscan that can provide scanning of a particular chain or transaction or some, a particular address, i.e. a participant in the market, to try and gather data, but it's extremely difficult. And the reality of querying a blockchain data set sort of goes as this. So you set up your infrastructure, you'll try and scrape newly minted blocks for relevant data. Each of those blocks is a new transaction. You need to ensure that the block is canonical, so it's sort of in the right order. You need to try and generate real-time notifications and logic, which is made easier with AWS, of course. You need to then aggregate from these multiple chains to store in a database, index the data based off of the chain, customize the queries and events with some sort of analytics tool or feature. And then once you receive new events, sort of have to trigger some application logic to send to another component of your application. Not very easy at all. But what the next year or 2 years of the blockchain and managed blockchain is aiming to do is to alleviate some of the pain points that a lot of our customers are seeing. Now, the marriage. Has anyone got any ideas of where machine learning might complement blockchain? Have we got any thoughts? Yes. Trading, that's a good one. Any others? It's not actually particularly easy to think of. I'd sat myself and didn't come up with many at all. Anyone else want to try and take a... Not to worry, we can go through some. Trading, price prediction, it's huge. A lot of the talent within Silicon Valley and Wall Street, I always do hate giving the Americans that they're all coming from one part of California, one part of New York, but talent across the world in technology and banking are moving towards crypto, not only because it's a get quick rich scheme, though in some cases it is, it's also a get quite broke quick scheme as well in the last year. But the fundamental technology behind blockchain and crypto, albeit not particularly simple, it is very powerful and has the potential to disrupt a lot of industries and already is. So as you said, a lot of very great talent trying to go into crypto hedge funds, and the markets are so volatile, it's so unregulated, which is a trader's dream in a way. These risky assets are being developed, but regulations can't keep up. A large number of individuals are highly leveraging themselves into a market they don't really understand, but there are some people that do understand it and are putting some of the most advanced machine learning towards it, and I think making good money. It's a good sign, not a good sign, but it's a sign that it's a strong market when some of the biggest institutional investors, JP Morgan or BlackRock, are taking it very seriously and setting up their own departments. First one, let's jump back to the first bullet point, energy usage reduction. So in the same way that Google's DeepMind, once it was actually acquired, was put towards trying to reduce the energy usage of the Google's data centers, there's a lot of research at the moment going into how the proof of work, i.e. Bitcoin's process for verifying the transactions, how the energy usage can be reduced a lot, because Bitcoin's not going anywhere. Neither is physical hardware to actually compute these cryptographic problems. So proof of work isn't going anywhere, even with proof of stake growing. The second is decentralized AI marketplaces. What does that even mean? It's decentralized in that it's essentially open source, but it's shared in a similar way to NFTs being sort of produced, verified, and shared. And it is people around the world with a particular AI algorithm and putting it on this marketplace for everyone to use. There's no payment involved. It is akin to something like Hugging Face, if you've heard of it, or even AWS Marketplace, where you can get some of the state-of-the-art algorithms from. We've gone through price prediction. In every industry, I mean, in all walks of life, there's fraud. The same is true in the crypto space. There are a lot of plucky individuals that are trying to fraud a lot of people of money, and machine learning is great for detecting fraud, and is almost an obvious use, but a lot of cybersecurity firms are putting money and time into this, and you can imagine it's quite a lucrative space. And now the last one, building an end-to-end AI-centric NFT solution. So I'm in between projects at the moment. I wanted to sort of take on a little project of mine that actually gave me an opportunity to learn a bit more about this space. So what I will walk you through now is one, state-of-the-art image generation in machine learning, and how I've sort of combined that into an AWS architecture to develop or mint and deploy an NFT on the managed blockchain. Does anyone know what that is? Not the picture so much as yes. Either one. Say in unison.
It's the latest version of faces. Like you give it some text and it will generate an image.
By AI, maybe the company might found by a public demo of the universe you can be found on places.
Spot on. So DALL-E 2 is the second version of OpenAI's state-of-the-art image generation, specifically text to image algorithm. Why DALL-E? DALL-E? It's a portmanteau of WALL-E, the Disney movie, if you've seen it, and Salvador Dali, the Spanish painter. I mean, it's an extremely impressive algorithm, which if we have time, we'll look to show you. But as this gentleman mentioned, you type in a very descriptive sentence and you get back a mind-blowingly accurate image. I will try not to spend too much time on the technicals or the architecture of this, given we haven't got too many ML practitioners and we're running out of time. But here is a high-level overview of how it works. So there's sort of three components we need to look at. Above the dotted line, we have this clip algorithm, which we'll come to in a sec. But what this aims to do is jointly learn a representation space for text and images. Below it, we actually depict the text to image generation process. What was the sort of entity or the algorithm above the dotted line? It's called the CLIP algorithm. CLIP stands for Contrastive Language Image Pre-training, and it's what's called a contrastive model. So it doesn't classify any images, but it works as such. It's trained on caption image pairs, and all of these images and captions can be found online. And it's essentially an image encoder that matches images to their corresponding captions. So contrastive learning, for those that don't know, is a machine learning paradigm where unlabeled data points are juxtaposed against each other to teach a model basically which points are similar and which are different, as you can sort of see in the image. And as the name suggests, the samples are contrasted against each other, and those that belong to the same distribution push towards each other in the sort of embedding space or the latent space, whilst those belonging to different distributions are pulled against each other. Away from each other, I should say. What are these embeddings? So we have an image embedding, which is generated by an image encoder. So CLIP trains two encoders at the same time, an image encoder and a text encoder, as we can see here. So the encoders themselves are either a transformer or a CNN. Does anyone know? Do people generally know what those are? It's not an issue. If not, CNN stands for convolutional neural network. And as we said, the text encoder turns text into text embeddings. And this is often a pre-trained BERT model or LSTM, long short-term memory model. And then what an embedding is, for those that don't know, is a mathematical representation of an embedding. It's just one really long vector of numbers. Our algorithms have no idea about any contextual information about the world. They simply, or at least in the case of the deep learning models, they operate just with numbers, huge numbers in large vectors, And a machine learning model or a deep learning neural network model, the parameters are just a huge number of numbers, all that are tweaked throughout the process to then be used for inference at the end. Nothing more. Now, the problem that CLIP, this sort of really important and innovative algorithm, is optimizing for is to ensure that the similarity between these text and image embeddings are sort of as large as possible, or the embedding of an image and an embedding of its caption the similarity is as large as possible. So it brings together the two different encoded representations into the same vector space, and then puts what's called matching caption image pairs close in this space. So if you see here the dot product of the two different text embeddings, the blue squares, we want that to be the greatest value, while the gray squares to be the smallest value. Apologies for the sort of great detail, but it's very interesting, I think. Going back to there's now going back towards below the dotted line. Once we've got our text embedding, we can then use a prior algorithm, is what it's called, and that can be, well, there are two types: autoregressive and diffusion. I won't go into them, but I will go into diffusion very briefly now. I won't go into both. I'll go into diffusion. What this is? Does anyone know what diffusion models are? I didn't know what they were either until I started researching this. So I finished my degree in 2018, and for two and a bit years, I was focusing on DevOps and MLOps. I then came back to try and read a machine learning paper, and I could not understand half of it. This space is moving phenomenally fast, and the diffusion model comes, in fact, from physics, but it's extremely advanced statistical mathematics to provide the most incredible results. But what this aims to do, the diffusion model, is you start off with a particular distribution, and then you really slightly add what's called Gaussian noise. So as you can see here, certain pixels are changing or in a way being removed of color. So then by the end, it's just a complete jumble of pixels. Then they try and reverse this process by reconstructing the image over each time step. So what this model aims to do is to model, to be precise, a series of noise distributions in a Markov chain, and then decode that by denoising the data. It's hard enough to understand what I just said. The mathematics is pretty heavy loaded, but if you're interested in this, I would advise taking a look at the paper. I think certain research groups do a good job of providing a high-level overview of how the algorithms are built or designed, and OpenAI are one of those groups. And then the decoder is also a diffusion model, but it's a modified one. But we also include the clip embeddings and the text caption itself. So at the end, you're creating an image conditioned on the textual captions that you input and the clip image embeddings. And in fact, I don't understand the upsampling entirely, but when they first create an image, it's 64 by 64 pixels. It's then upsampled to be 256 by 256, and then to the resolution that a lot of us are accustomed to, sort of on the right, sort of 1080p type. It's then 24 by 24. Now, bit of fun. These are some of the images produced by the algorithm. So I thought it might be quite entertaining if people could try and guess what the textual caption was. So starting top left, who wants to try and have a guess about what someone inputted to get that? And if no one puts their hand up.
It's interesting because there's a similar thing going on at the moment with photography. You type in exactly that.
Exactly.
It's very, very interesting.
Does no one want to have a go?
Is it just astronaut riding horse in space?
Yeah, it's very, very, very close. An astronaut riding a horse in photorealistic style. Second one is a propaganda poster depicting a cat dressed as French Emperor Napoleon holding a piece of cheese. Now, the paper itself goes into a lot of detail about why this is the case, but the more descriptive description you provide, the better the image will be, and that's because the semantical understanding of the model is so good. The more you can provide it, the more it can be like, okay, yeah, well, I know what that is, ironically. Third one, a teddy bear on a skateboard in Times Square. I mean, how real is that though? It looks like something out of TED, doesn't it? Fourth one, bottom right, a corgi's head depicted as an explosion of a nebula. Crazy. I mean, it almost seems like a joke, but that's... It looks like someone's taken an image and gone, right, how can we be as literal as possible about it? But the reverse is what's happening here. Then the final one is panda, mad scientist mixing sparkling chemicals, art station. So a key part of this model is if you, in any part of the description, say, in the style of Van Gogh or digital art or 3D model or 3D rendering, it does exactly that. I found an online version of DALL-E written in PyTorch. I ported it over, or just cloned it into a Sagemaker notebook and trained it up using the wise words of some very smart people in GitHub. And these are the results. They're not fantastic, but it's what I've been using as part of my product that I've been designing. Not quite as good as OpenAI's, but what have we got? We've got 1950s diner I typed in. The third one on the top is Elvis Presley as an elf, which is quite amusing results. Top right, very top right is my favorite. I just typed in astronaut poker. It's sort of strange for those Yu-Gi-Oh fans out there. Bottom left is Blue Eyes White Dragon, which came out looking like a bit of a scary chicken. And the very bottom one is Viking Hall filled with priests. So even if you don't have the compute power that OpenAI do, or have tweaked it exactly as they have, or have the same image data set, you can see that the technical underpinnings, the theoretical foundation of this model is strong enough for people out there to be generating these kind of results. What I did happen, I mean, you mentioned you can find a beta for DALL-E 2. I had to sign up and got it the other day. You get a certain number of credits to produce the artwork that you want. So I put some in. I did not Times Square, but Trafalgar Square, bottom right. Top right, I just did a goldfish in a bowl, but it came out looking like Dory, which I thought was quite cute from Finding Nemo. And my girlfriend loves Dobermans. I typed in a Doberman in front of a Tuscan villa. I mean, they're all in their own right interesting pieces of artwork, and you want to look at them, and you'd think it'd be the hours of work put in by an actual artist, a digital artist. Bottom left is an oil painting I put in at the end, and it looks like an oil painting. It's incredible. I mean, it's a very versatile model that can just go beyond just the sentence to image generations. This, I wanted to show you, final image, and I appreciate we're nearly running out of time. Someone typed in a very long sentence and it came out with something so whack. So this is a shipping container with solar panels on top and a propeller on one end that can drive through the ocean by itself. The self-driving shipping container is driving under the Golden Gate Bridge during a beautiful sunset. I mean, that's more than that. That's two sentences. I mean, no person in the world has a mental repertoire of visual representations that can equal this. I mean, someone could describe that to you, and you can maybe come something close to that, but we've obviously never seen that. Well, I've never seen that. Has anyone seen that? And therefore, we can't really think it up. So, in terms of its raw capabilities, this model is exceeding not human imagination. I don't want to take it that far, but something the closest thing to that. Now, to talk about sort of the final use case or intersection of the two sort of domains is what I've been working on over the past couple of weeks. And this is just an end-to-end AI-generated art NFT solution. And so what it does at its core is enables sort of an NFT creator. And for those who don't know, that stands for non-fungible token, to deploy a particular Ethereum contract to the public Ethereum testnet and to mint an NFT. Does anyone own any NFTs out of interest? It's interesting to hear. I don't either. I don't really there's one thing owning it for the sake of thinking it's nice and it's an asset that you one day might have in your metaverse home. But I'm not one of those people either that is sort of going out there to try and make money off of these NFTs. I'm not. Anyway, one use of NFTs is digital art. Another is sporting memorabilia. They can represent digital collectibles like physical card collecting. I used to do that when I was a boy, but in, of course, this completely digital format. So a lot of big sporting companies are taking that on. And these bodies can increase fan engagement, tokenizing iconic moments in the sport, when a goal was scored or a hoop was dunked. Gaming as well. There's a huge amount of money in this. Blockchain-based games and in-game purchases of collectibles is a growing source of revenue for gaming companies. Same is true of event ticketing, supply chain, and patents. I mean, an NFT is just sort of a proof of ownership. A patent is a proof of ownership of an invention. So it's very, very much applicable. Talk you through the architecture, back to familiar ground, I think, for a lot of us. So as I mentioned, what this aims to do is an NFT creator can transact on the far right, the RIGB testnet, via what's called an Ethereum Geth node, sort of Go Ethereum node, which is in a way a sort of the most physical way of describing or an instantiation of a particular Ethereum virtual machine on a particular node. It provides some sort of computation. So to initiate the creation, I send a JSON RPC request containing information about the NFT I've created, which in this case was an image outputted in Sagemaker. I need to bridge that gap, and I'm looking to do that soon. That then forwards the request to AWS Lambda. The Lambda is configured as a proxy integration and has logic to deploy, mint, and get the ownership of the token. That information forwards the request to the managed blockchain HTTP endpoint. So it's similar almost to the Sagemaker endpoint in that regard, which then signs the signed transaction to the Ethereum blockchain. Now, it sounds like a complicated thing to do. I didn't know how it was done before, but in fact, the Lambda function itself is not particularly complex. It's just a small Node.js script with a few imported functions to do this. It's really not very difficult. And Solidity, the sort of Ethereum language, is also very intuitive. Now, the transaction sent to the network may in fact take a couple of minutes to be confirmed, depending on the network traffic. But if you need to wait a certain amount of time, and then you'll get a response back. AWS Fargate is polling the blockchain, checking for a certain number of required confirmations, and then when those confirmations come through about it being deployed and minted correctly, Fargate then sends an SNS notification to you, the creator. What am I looking to do going forward? There's a couple of things. One, actually haven't put on the slide, is to integrate it with Amazon Alexa. So you would say, hey, Alexa, make me an NFT. And then you would speak the textual input. You'll say, a teddy riding on the moon or something crazy that people have been inputting. And then the whole process will be triggered. And rather than me passing in a file location on my laptop to the API request, it will just go to S3, and then the API gateway will trigger it from there. But other than that, I'm working with a senior solution architect blockchain developer to create a rudimentary interface for a consumer to interact with. We're talking really basic for the sake of our blog. And then users will start the process of basically buying an NFT using money in a fake wallet, and then the Lambda will mint the NFT straight to their wallet. He has stated that it's a really important use case a lot of his consumers or customers are looking for, and so that's what's going to be the focus of the next couple of weeks. With what looks to be 50 seconds left, sorry, but I've run a little bit. That's all. Thank you very much for coming to listen to me. You can reach me on my email address. I'd love to hear your thoughts. Sadly, I won't be able to stay towards the end for the pub because I need to get the last train before the strikes tomorrow back to London. But it's been an absolute pleasure.